Welcome to The Explainer. Today we're diving into a theory that is so out there it really forces you to question the very fabric of our universe. What's so compelling is that it all starts with a single number, a cosmic coincidence so precise you just can't ignore it. It feels like it has to mean something. So this entire massive idea really just comes from one single shocking calculation. And look, it doesn't give us the answer, but what it does is force us to ask a question that sounds almost unbelievable. I know, it sounds like something straight out of science fiction, but hang with me here, because this isn't just idle speculation. It's actually rooted in a really startling coincidence that pops out when you look at the fundamental numbers of our cosmos. When you do the math for the mass of our observable universe, the result is, well, it's just a little too perfect to ignore. So what are we looking at here? This number, this, 1, represents a near-perfect match between two incredibly important cosmic scales. On one side, you've got the short-shelled radius. That's the size a black hole would be if it had all the mass of our universe. On the other side, you've got the Hubble radius, which is basically the size of our observable universe itself. For these two totally different calculations to come out identical, that's either the most staggering coincidence in the history of physics, or it's a massive clue pointing to the true geometry of our reality. Okay, so to really unpack what that number could mean, we need the right tools. And for that, we have to go straight to the source, Einstein's general relativity. You can think of it as the fundamental operating system that governs how space-time itself works. At its heart, the Einstein field equations describe this beautiful two-way street. The geometry of space-time, all its curves and warps, tells matter how to move. But at the same time, all the matter and energy within spacetime is telling spacetime how to curve. It's this constant, dynamic dance that governs everything from an apple falling to the ground to how entire galaxies orbit each other. And this just perfectly illustrates the sheer power of these equations, right? They predicted these tiny ripples in spacetime a full century before we could build instruments sensitive enough to actually hear them. So the discovery of gravitational waves wasn't just some neat confirmation. It was profound proof that this mathematical language is an incredibly accurate description of the reality we live in. All right, now for the first major plot twist. What if our most basic, fundamental observation about the universe, the fact that it's expanding, is just a matter of perspective? It turns out, general relativity actually allows for this mind-bending duality in how we can look at that expansion. Think about it like this. Are you watching a stage get bigger, or are the actors on it just getting smaller? From your seat in the audience, the effect looks exactly the same. So the redshift we see from distant galaxies could be light waves being stretched out by expanding space. Or it could be that space is perfectly static, but our atoms, our rulers, our measuring sticks are constantly shrinking, making that ancient light only appear stretched by comparison. And this isn't just some fun thought experiment. It's a mathematically solid, totally valid duality in general relativity called a conformal transformation. All it really is a change of coordinates, a different lens for looking at the very same physics. And this alternate perspective, well, it's absolutely crucial for what comes next. Okay, so let's take that shrinking ruler idea and bring it back to our original, shocking coincidence. What if the reason the universe's size so perfectly matches its short-shelled radius is because we are, in fact, inside a black hole, and our shrinking rulers are simply the effect of us falling inward? If you accept this framework, it completely reframes your entire picture of the cosmos. That expansion we see, that's just the geometric effect of our free fall towards the center. The edge of the universe, it's not a real place. It's just your own personal observable horizon. And the singularity at the center, this is the craziest part. It stops being a place in space. See, inside an event horizon, space and time kind of swap roles. The singularity becomes a moment in the future, an appointment that everything inside that black hole is destined to keep. Now, this is where we push things one step further. We're heading into territory where physics starts to feel a whole lot like metaphysics. Because if our universe is one big black hole, what about all the other ones out there? Could there be a connection between them? This is the ER equals EPR conjecture. It's a radical idea that suggests quantum entanglement, what Einstein called spooky action at a distance, is really the same thing as a wormhole, just viewed differently. Now, here's the leap. What if this doesn't just apply to tiny particles? What if the supermassive black holes at the centers of galaxies, which were all born from very similar conditions, are themselves entangled on a cosmic scale? Well, if ER equals EPR can be scaled up like that, then our universe suddenly stops being a collection of isolated islands of matter. It becomes a single, vast, interconnected network. The galaxies are like nodes, and these supermassive black holes at their cores are like synapses, all linked by these wormholes. Information that falls into one isn't lost, no, it's processed and shared across the entire cosmic web. And this is the profound implication, the really big what if. If this is true, then maybe consciousness isn't some random biological accident that just happened here on Earth. Maybe it's a fundamental, scale-invariant property of the universe itself. The same exact pattern of networked information processing, just repeating everywhere, from the neurons in our brains to computers on the internet, and yes, even to black holes in a galactic network. Okay, that is a lot to take in. Before we get totally lost in the metaphysics, let's pull this all back down to science. Because, look, extraordinary claims require extraordinary evidence. So the real question is, how on earth could we ever test a theory this grand? The cool thing is, this isn't just philosophy. The theory actually makes specific, falsifiable predictions. For instance, if a black hole's event horizon isn't just a point of no return but some kind of physical surface, then gravitational waves should actually echo off it. If our atomic rulers are really shrinking, then fundamental constants should look like they've shifted when we observe light from the very early universe. And hey, if our entire cosmos is falling in one direction, we might just be able to detect a preferred direction, an asymmetry, in the cosmic microwave background radiation. What's so fascinating is that right now, this whole framework exists in this strange state that some physicists call not even wrong. It just aligns so perfectly with the mathematics of general relativity that it's hard to tell it apart from the standard model. And while all these tests are ongoing, there are already some intriguing hints that line up with its predictions, like the so-called axis of evil, this weird large-scale alignment in the cosmic microwave background that our standard models just can't explain. The point is, the theory is testable, and so far, no one has been able to break it. So this all leaves us with one final, provocative question. If this framework is correct, are the laws of physics just the operating system for a universal computation? A process that's been running for nearly 14 billion years inside a machine the size of the entire cosmos. And are we simply passive observers of this process, or are we somehow a way for the universe to think about itself?